flip a fair coin 9 times and aim to find the probability of getting exactly 4 heads among the tosses. So what this basically boils down to is thinking of this question as an ordering problem. And what I mean by this is we have to take exactly 4 heads among 9 tosses. So if we have 4 heads, then we have 5 tails. How many distinct arrangements of this sequence are there? So if I numbered h1, h2, h3, h4, this is the same as h, 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 t, 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 but let's say I swap 1 and 2, right? Because ultimately, this permutation and this permutation both involve getting 4 heads, for the first 4 times. It doesn't matter like which coin produced a head. All that matters is we found a head, and that's all that matters. And the reason why I bring this up is because as you're counting stuff, which in this case you're counting, it's important to make the distinction between distinguishability and indistinguishability. So this is a perfect example of indistinguishability because this permutation 2 is the same as permutation 1. So how do we go about doing it? Well, we use combination. Out of the 9 tosses, we want 4 of the 9 tosses to be heads. And this basically gives us the number of permutations of 4 heads among 9 tosses where the order of h1, h2, h3, and h4 doesn't matter. After we chose the 4 heads, well, these 4 heads have to be heads. And so each has a half chance of happening, so we raise that to the 4th. And now for the remaining 5 coins, they all have to be tails. And each one has a half chance of being a tails, so we raise half to the 5th power. And that's it, that's your probability. So that becomes 9 choose 4 times half to the 9th power. So 9 times 8 times 7 times 6 divided by 4 times 3 times 2 times 1 over 2 to the 9. Now 8 is the same thing as 2 to the 3. 6 is the same thing as 2 times 3. 2 and 2 can cancel. 3 and 3 can cancel. So now we can subtract the exponents. So this becomes 6 and 4, right? And this is gone. And this becomes 2 squared. So this is 36 over 2 to the 8. Now we know that 2 to the 10 is 1024. So therefore 2 to the 8 is equal to 1024 divided by 2. And that's supposed to be 63, which is equal to 512. So, divided by 4, not 2, right? Because we're dividing this by 2 squared. So that's equal to 256. So that is 63 over 256, which is your final answer.